Applications of differentiation, maximum and minimum problems. The theory here is that the maximum or minimum of a function can be found because the derivative of the function would be equal to 0 at that value. In this question, we see a rectangle is being formed by using the positive x-axis, the y-axis, and a point B that is on the line 2x plus y equals 6, as shown in the picture. Part 1. Find an expression for the area A square units of the rectangle in terms of x. Now we could see the area of a rectangle is length by breadth, and we could see that the length of this is maybe x units and the breadth is y units. So x times y is the area, but we want it in terms of x, so we need to express y in terms of x. That's what we're going to do first. So if we write the equation of the line, express it in terms of y, we'll have y expressed in terms of x. So y is negative 2x plus 6. So we could write b in terms of x like this. And the area is x by y, because it's length by breadth. So whatever the x coordinate is multiplied by the y coordinate, that would be the area of this. So in terms of x, we could express that as x being multiplied by negative 2x plus 6. This is the solution. However, we might multiply it out. I'll do the positive term first. X by 6 is 6x, and x by negative 2x is negative 2x squared. And this is measured in units squared. We don't know what the units are. So that's the answer to our first question. Next, we're being asked, what is the domain set of the values of x? Well, we can see here, because x is formed in the positive sense of the x-axis, the smallest value that x could have is 0, and the largest value that x could have is 3, because that's where the line crosses the x-axis. So the domain of this function, the domain of y, is between 0 and 3. However, it does not include 0 or 3, because if the point B was on the x or y axis, it wouldn't form a rectangle. It would be a flat line. So that's the second answer. And the final question, we're being asked to use differentiation to find the maximum possible area. Well, we have an expression for the area, and the area will be maximum when its derivative is equal to 0. So we'll differentiate the area function. So we differentiate 6x and get 6, and negative 2x squared and get negative 4x, multiplying by the power, reducing the power by 1. Now this equals 0, so 6x minus 4 equals 0. If we add 6 to both sides and divide by 4 and simplify it, we see x is equal to 3 over 2 units. Now we want to express this in terms of the area. If x is 3 over 2 units, what would the area be? So we sub this 3 over 2 back into our area expression. You could use a calculator to evaluate this. And we see the answer is 9 over 2 units squared, or 4.5 units squared if you wish.